have kinetic energy. What is kinetic energy? Now instead of focusing on this bow, now focus on this arrow. The energy possessed by a body due to its motion, energy possessed by a body due to its state of motion, this is actually called a kinetic energy. So energy possessed by this arrow, okay, this energy possessed by this arrow which is in motion, it is having kinetic energy. Okay, like the expression we have done from the gravitational potential energy, let's make a one expression for kinetic energy. Let's see the expression of kinetic energy, in which a body which is moving with some initial velocity is stopped by a force F, creating a retarding force. It acts as a retarding force. So initially this body is having some initial velocity v, final velocity of this body is 0, it is having some mass and stopped by some retarding force. So acceleration in this case is actually a retardation, negative of acceleration is produced and displacement covered by a body is s. Now we have to derive the expression of kinetic energy. Before that we should know what is kinetic energy. Kinetic energy is the energy required by a body to come to rest if it is moving with some initial velocity. Means a body is moving with some initial velocity, how much force is required, how much work is done on the body to stop the body, that is called kinetic energy. So we have to calculate work done, which is force into displacement. Force, we have mass into acceleration into displacement. Now we need the expression in velocity, so we will use the third expression of Newton's law, that is v square minus u square is equals to 2as. Final velocity we have 0, initial velocity we have v square, 2 acceleration we have minus a, it is retardation, and displacement s. So minus v square is equals to minus 2as. So here we got v square as 2as. So from here calculate the value of s as v square by 2a. Put value here. So here displacement we have v square by 2a. So a and a cancel out. Work done we got here as half mv square. So this work done is actually a work done to stop a moving ball. So this is actually a kinetic energy which is half mv square, and kinetic energy is denoted by the symbol k. Clear? Now let's see again the definition. So definition we have: kinetic energy possessed by a moving body is equal to the amount of work which the moving body can do. It is the amount of work which a moving body can do before coming to rest. So before coming to rest, whatever is the amount of work done we have calculated, that is a kinetic energy. So we have calculated kinetic energy as half mv square. Now let's see what is the effect of changing mass and velocity of a body. For example, a body is having some mass m moving with velocity v. Clear? Now it is having some kinetic energy k, which is half mv square. Now if I increase the mass to 2m and velocity remains same, what is the change in the kinetic energy? What is the new kinetic energy in terms of old kinetic energy? So new kinetic energy k dash we have 1 by 2 m become 2m v square as it is. So here it become 2 times half m v square. This 2 is coming out and this is the old kinetic energy. So 2k. It means that new kinetic energy we have double times the old kinetic energy by increasing the mass to twice of its value. Now do the same expression for velocity. Means, for example, a body is having mass m moving with some velocity v. Now keeping the mass constant and increasing the velocity to 2v. So initially it is having some kinetic energy k, which is half mv square. Now calculate the kinetic energy. New kinetic energy k dash we have half m v, we have 2v. So 2v whole square we got 1 by 2 m 2 square into v square. 2 square take it out from the bracket, which become 4 and half m v square. So this half mv square is again a kinetic energy 4 as it is, and it is k dash. So new kinetic energy will become 4 times the initial kinetic energy. It means that when mass we are getting doubled, kinetic energy will become double. When velocity we are getting double, then kinetic energy become 4 times. So the effect of velocity is more on the kinetic energy as compared to the mass effect. Clear? So kinetic energy forms depending upon the type of motion. For example, we have basically 3 types of motion. When body is moving in a straight line, that is called translational motion, and kinetic energy related to that is called translational kinetic energy. Second, we have when body is in rotational motion, the kinetic energy associated with the body, that is a rotational kinetic energy. Third, we have when the particles are vibrating about their mean position, the energy associated with the body is called vibrational kinetic energy.